Let's see. So I want to give a talk about something we call the rules for success of AI-based business process automation. And it's a bit long title and maybe not the nicest one, but we will find out what's behind. Basically, I have three major points I want to tackle. I give a short motivation why business process automation and AI are heavily needed. And then I want to point out something that I call foundations for the solution for the success of AI-based automation. And at the end, we want to talk about these rules. What are these rules, and why I stated here no rules, no automation, right? So let's dive into it. First of all, some words again to my side. I already introduced a bit myself. I have a strong background in software engineering and also in semantic data. So as you see, I'm not a native AI machine learning guy, but nevertheless, over the last years, I developed a huge passion for, let's say, modern software architect on the one hand, but also on product-based AI solutions on the other hand. And as a third kind of thing I really love to work on is like how to define agile organizations, how to enable them to grow. And that's what I do also in my day-to-day work now as a CTO of elevait. And if we start a bit more on a broader level, I mean, everybody in this call is kind of related to AI and probably is aware of that there's this huge hype of AI technologies, right? So many people, many customers as well in Germany want to apply AI, they want to benefit from it. So there's a huge market and many people want to invest in this market. So it's pretty good for us as vendors to provide solutions in this area. But as always, there's a huge but. Still, it's the case that many like statistics or researchers show that most of the projects aren't really successful in the sense of they really help companies to improve, like being more cost efficient or being more faster in their process or whatever. Most of the time, these AI-based, let's say, projects end up in being something like a pretty shining object that can be shown to the management as a cool prototype, but they won't really fly away and bring any benefit to the companies. And the question is why this is the case and why many companies struggle so a lot with applying AI technologies. And one of the major barriers that was identified in research is definitely the lack of skilled people. So we all know that there's a huge gap of IT experts being needed in the industry. And this also is true for, let's say, machine learning experts, deep learning experts, AI experts, data scientists. And if every company wants to have their own, let's say, machine learning team, this isn't possible at the moment, right? You won't find so many people that could help you inside your organization to grow as an AI expert team. And the same thing we already tackled a bit with Alexander now in the discussion is that a lot of time we lack in good data, right? So, I mean, as Alexander always said, like many people say they have a lot of data, but the question is this data good or not? Because if we have no good data, and no good data means it's not labeled correctly, it's not classified correctly, it's not whatever, annotated correctly, we end up in an AI solution that's exactly not good, right? So the AI can only do what you give him as input. And the third aspect that also is a big barrier is like the infrastructure. So if we imagine every small company in Germany wants to have an own GPU server to do some predictions or trainings, it's really costly for them. We know that at the moment, like delivery times and availability of IT equipment is quite hard. And so this doesn't scale, right? So it's not the perfect idea that every company will have their own training infrastructure and AI model delivery infrastructure. So we need to find another way how we can approach companies in Germany or also worldwide to make use of AI without having the AI expertise in their organization itself. And this was basically the reason to found elevait and to work with elevait. So we dedicated ourselves to offer, let's say here it's a superior, easy to use, but more important AI-based software products. So we don't want to make one additional AI project with a customer, which gets then being shown as a pretty shiny thing, but not being used. And we want to make AI usable for especially small and medium-sized companies out of the box, right? This is the kind of vision behind. So we want to enable them to just use AI without understanding it, without making any efforts into it, just buying it as a product and applying it. And to reach this, we focus on the area of business process automation and in any kind of organization. And the goal is at the end to make processes more cheap, more quick, and to enable people in these processes to focus more on the, let's say, inspiring tasks and the cool tasks instead of these repetitive tasks that you have to do all the day. Yeah, I quickly skip over this one, I guess, but like Elevate itself, it's just like, as I said, a software-based company. We started up there was some predecessor company founded in 2017. We started with 5 people in a co-working space. Meanwhile, we have 75 people with 15 nations, so quite diverse team, quite cool and young agile team. We have 2 locations at the moment. One is in Dresden, which is our major development location, and a small location as well in Triberg. It's in the Black Forest, probably known by nobody. What are use cases we are talking about when we talk about process automation? At the moment, with our products, we heavily focus on document, text, image-centered processes. So every company in Germany has kind of these processes. The first example I like to show here is one of our customers called User. So we can use them as our reference use case. They have a typical order process, how you can find them in many, many small, medium-sized companies in Germany. So they offer medicine individual products. So as you see, it's something around trousers that needs to be measured individually and then produced. And sadly, even in the year 2022, these orders are placed by a fax machine. So they reach over 3,000 pages per day via fax or even by email, but basically at the end they get an image of these documents, so nothing is natively digital, and they had no chance to digitalize their customers because their customers are pretty small, let's say drugstores or individual persons that wasn't convinced to use a tablet or whatever for putting in the data. So they needed to digitalize on another layer, and they came to us and we digitalized their order management. Instead of, say, every time such an order is reaching the system, we have some models trained on it that, for example, detects these handwritten fonts, puts these numbers to the system, detects the customer number, checks the validity and stuff like this. The same thing we do also for more open layouted documents. So you can imagine invoice processing, delivery note processing, and stuff like this. So we have a neural network trained on that detects, first of all, word bounding boxes, as you know, it made from OCR solutions. And based on these word bounding boxes and the content, we predict semantic meaning of boxes. So we can extract the invoice number, the total amount, and stuff like this from any kind of document. Finally, or not finally, thirdly, we have a product which is focusing only on text-based content. So we have customers that manage their ticket system or complaint management over our product. So with this product, we can take texts and first of all can classify them into what we call an intent. So an intent could be something like cancellation or want to start a new contract or whatever. And as soon as the intent have been detected, we can apply something that's called slot filling or known as slot filling, where we can find out what is the reference number of this customer, what is the desired cancellation date, and stuff like this. And finally, we also have a product that tries to apply similar techniques to the domain of 2D construction plans. So we can use these plans, or we can extract from these plans geo information. We can extract the header data, and maybe can use this information to merge different plan areas to a bigger plan and stuff like this. Okay, but if we talk about these kind of processes and that we want to automate, right? We want to ideally process like the documents we saw automatically through a pipeline and give the output as it's needed to the target system. And the target system could be something like SAP we heard about as an ERP system, but it could also be a CRM system like Salesforce or whatever. And to automate such things, we did a journey, and while this journey was happening, we learned something. And that's what I want to share here. So the first thesis of what is the foundation to be successful is we need to have atomic tasks and generalized models. What does it mean? So if we have this task to automate like this document workflow, which I described from user, what could it look like? One option is we have one customer, so we have one task, we have one model. We get the document as input, and then we train a model that tries to predict for each page we give him where are the areas of interest, where are like the handwritten fonts given, how can we extract them, what is the value of the customer number and stuff like this. So there could be one dedicated model doing exactly this job. At the end, the customer needs to have a kind of XML schema or structure. We put it out and deliver it to him, and he's really happy about it. But the problem is, if the next customer comes to us and say, I want to have exactly the same thing as user had, but the forms look a bit different and they have a bit different of information inside, and actually I have another XML schema you need to supply. We start up exact at the beginning at the same pipeline again, right? So we need to retrain the complete model, we need to annotate data, we need to have good data being labeled and so on and so on. And this is repeating all the time when we have a new customer. And this is quite obvious, right? So it's not working because it's a huge monolith and we have a high cost per customer. And previously we talked about that especially small and medium-sized enterprises need to be supported to apply AI. And if they need to like finance this whole process all the time over and over again, it's not working for them. And the same is like the time to market is pretty long, right? We need to really start from scratch with annotating, training a model, try it out and stuff like this. So we can reuse nothing we had done before, and this is quite bad from a software architecture perspective. That's why what we did in our products, we try to separate it, the single steps needed for an automation pipeline into what I called here atomic tasks. Probably you immediately think of it's a kind of web service, microservice architecture. It's exactly like this. So we try to separate each atomic step into a single service. And while doing this, in combination with AI, we have the advantage that we can train more, let's say, smaller, dedicated models that are more easily generalizable, right? So this process which you see here is not, let's say, the real process we have. I tried to ease it a bit so that you understand the basic idea. But let's see, if we look at the first example, how can we bring it down to atomic tasks? So, okay, if something comes in, we need to kind of classify it to know what is the type of document we see. Based on this information, we can maybe rotate the image to make it straight. We can detect where is handwritten font on it, and we can have a model that's only there for extracting handwritten font given on a small snippet of handwritten font. And then we put it out as XML. And the advantages, again, like if you look at the handwriting extraction, we can train a model that only is able to get a snippet where some handwritten font is on and predict us what is written there. It doesn't need to know the context where the snippet is from. It doesn't need to have any knowledge about the document where it was placed on. It is just trained on snippets of handwritten font. And this is then capable to generalize for more customers, right? So if a new customer comes in this example, we do not have to replicate the whole pipeline. We can only replicate the really customer-specific parts at the beginning, but the rest of the pipeline, we hopefully can easily reuse. Surely it doesn't like have the same quality for a new customer than for an existing customer if you have never saw data of the customer. But our approach is always to deliver a really fast first solution with, let's say, a base quality and improve the quality over time while using the system. This is a really important aspect for all of our customers, that they can really see something quickly instead of having half a year of project of annotating data, training, and then evaluating and stuff like this. So the reusability in this approach is way higher. We have way less costs per customer because we can share the costs between all the customers that use this product. And we have a really, as I explained, a really fast time to market. That's why this is our core decision in our whole pipeline of all our products. We separate into atomic services and we try to generalize each of the models behind these services. The second thing, and this is also kind of related to Alexander and Christoph, is it's really important how you structure your data model. Right? So I wrote here as a foundation, generic data structure, and mapping. What do I want to say with this? If we look at our pipeline as we saw it before, we see in the middle part, nice, we have this microservice-based dedicated models. They are generic, we can use them, that's pretty cool. But nevertheless, customers need to integrate into their system, right? So they have some system that delivers, in our case, let's say a PDF with a certain format. So we need to process this PDF for the customer. We need to create a data model where all outputs of each single service or each single model are bound and extended, right? So we have the output of the handwritten extraction, we have the output of maybe the customer number extraction and stuff like this. All these information needs to be persistent anywhere or somewhere. So, and at the end, if we're ready with our pipeline, these persistence layer need to be exported in a format the target system is understanding. So if we talk about Salesforce, there's probably another format than we need to deliver if someone is using SAP or whatever. So as you see, we have our core, which is quite generic, but nevertheless, around these core, there are really customer-specific adaptations needed as well. And what is really heavy and it's really painful from a software perspective is this data model, right? So every time we have a new customer, we potentially need to update the data model. We need to make new schemas, mapping between these services and stuff like this. And so in my second example, I just wrote like there's a similar customer with another document. Definitely they want to have JPEG images as input, and they want to have Excel as export. And we thought, how can we improve this? And it's maybe also a bit matching to the presentation before. We thought it's only possible if we have a common data model for all our customers and products. So this sounds a bit weird, but it's possible. So from a schema perspective, it looks like this. So in the middle part, you see that everything's black, which should like imply that it's generic. It's not customer specific. So it means we saw before here in this area, we have a PDF processing and a JPEG processing. Still it's there, but we made a general component out of it that says, no matter what I get, I will produce one unique format out of it. So in our case, we use in our pipeline only PNG images for everything we get. No matter whether we get a TIFF, a PDF, whatever, we convert it to a single page PNG image. So we are completely independent of the format the customer is approaching us. The only thing we need to do is we need to have a kind of input mapping that enables us to connect to the actual target source of the or source of the customer. So we need to say, is it the SFTP server? These are the credentials. This is the folder we need to observe and stuff like this. But this can be done in a non-programmatic configuration file, right? So it's nothing someone needs to program or code. It's really like only on configuration level. And the same thing we need to do on the output side. So if we have a really generic data model that we can apply for every customer, maybe also every product we have, we can easily have a generic export function. And we only need to map to the actual output format of the customer. So how this is working, the data model has generic attributes. And these generic attributes could be something like it's a customer number, or it's just a number. And then in this mapping, we say our concept of customer number, which is like our ownership, should be mapped to the XML field called C number or whatever, right? So we just need to create a mapping between our naming of attributes and the actual customer naming. And so we reach that if a new customer is using the product, we can keep the inner core or the major part of the software same for every customer. And we only need to adapt the input and output mapping by just giving a configuration. Surely this is like the theory, right? In practical, there are a bit more adaptations needed, especially from the mapping part and stuff like this. But all in all, we already reached that we could like bring out the customer specific adaptations to the outer edges. So either on the input or the output. And this was like a huge factor for success for us. And if you imagine, okay, how could such a generic data model look like, right? It's really easy. It's we invented like a resource that could either contain, again, another resource or a resource attribute. Sounds simple, a bit weird, but it's that simple. And We use as foundation RDF. So we have a semantic data model. It's linked data. If you have never heard about it, don't care. It's something very specific for semantic web, but it's getting more and more popular. And based on these RDF data, we can do something like this. So if we have on the left side, sorry, it's in German. I try to explain it as best as I can. We have like some snippet from an invoice maybe, or from an order. We actually do not care in our data model what is the layout behind this information. At the end, we just care what is the semantic meaning of this information and how it's being structured in the form of a hierarchy. So as you see, there's something someone wants to order. So we create a resource. And this resource obviously contains two things, because there are 2 lines in this table. So we create 2 resources out of it. Don't saying that it's anything about ordering. Don't saying it's anything about payment. It's just a resource, right? And then we try to predict the meaning of each of these attributes. So, and as you see, these are columns in the table, but in our data world, it's just something as an object that has attributes. And these attributes will be predicted by one of these atomic services. And also these values being predicted by another of these atomic services. And so we are quite flexible in combining different services, creating always the same structure. And then at the end, we just map this structure to the final format the target system is required to have. Okay, but now still we didn't talk about rules, right? I mean, the time is running. I need to hurry up a bit, I guess. So what is about these rules? If we look at the process we talked about before, it could look potentially like this. It's really an easy one, a simplified one, but just that you get the idea, right? There could be a booking process or order process. And so we get in a document as shown before. We extract everything from this document which is needed, customer number, all the numbers, all the dates, all the names and stuff like this. Everything was totally fine. Then still there's a process step needed that validates formally whether everything is correct. And there's a second step. There's something needed that validates whether the content is correct, right? So for example, is the customer number really existing at our company? Is the product article number really existing at our product backlog and stuff like this? If this has been done, we need to approve, we need to say, should we adapt something because there was something wrong? Can we approve it? And if it's been approved, maybe we can directly, let's say, book it or whatever, pay for it, and inform the corresponding team members, whatever. And if you look at this process, you see that there are 3 kinds of tasks. It could be something that could be solved with current machine learning methods. There's something that could be solved only, I actually say it like this, with formal business knowledge. And there's something that still humans need to do, right? So the idea to completely automate processes is most of the time not really possible, because there will be a certain point in time when some human needs to decide because it's critical from a law perspective or something like this. So, and if we go to the process, we see extracting documents we saw already is definitely possible with AI technologies. But if we look at the next 2 steps, validating whether something is formally correct or validating whether a content is correct is quite hard or even maybe not efficient while using AI technologies. So here's what we call the rule comes into the game. So if we do an extraction only on, let's say, OCR level, probably we will never be able to automate this process completely, because it needs to definitely have a valid content, because otherwise the target system like SAP, Salesforce, whatever, will neglect to accept our results, right? Because, for example, in SAP, it's configured that a customer number needs to be valid to start a new order process. And if our solution would deliver an invalid customer number, it will just say, sorry, I don't take any of the data. So this complete order process would be failing. Due to time, I will skip the next ones and just want to show you some examples. So what could this rule-based knowledge steps could look like? So one example is here. If you have ever worked with classical OCR technologies, you have probably seen this case, right? So you have some image, it's even a really worse one. You get an extraction that is totally fine, right? You really, as a machine learning engineer, you're really happy you found out of this picture, we was able to detect this string, but nevertheless, the system doesn't accept this type of date format. It needs to be exactly this type of date format from a technical perspective to be successfully integrated. And this knowledge, what format the target system accepts, isn't worth to put into an AI, right? It's a rule-based approach to convert dates to this format. And the same goes on for content validation. So if we have a customer number, we can extract the string, but we do not know whether the string is really a valid customer in the database. So we need to have some rule-based approach that checks whether the customer number is valid or not. And this lastly continues in the most powerful part, even of our product. It's what we call knowledge inference. Because since we are using an RDF-based data model, we can have some inference rules being attached to it. So that means, let's look at these snippet here. It's just the selection of the gender of our customer. And in this example, nothing was crossed. So that means the AI or the OCR, whatever, will predict there's no extraction, right? Nothing to extract. Yeah, but then there's a rule that says there have to be exactly one gender information being present, otherwise it's not a valid order. So it means we can infer a knowledge to this extraction. We can add the information that this order is not valid by a simple rule, right? So it's nothing that comes from the AI. It's a rule on top of this AI that tells us that the extraction is not valid because the gender information is missing. And the cool thing is, you can immediately flip this rule, having the same AI being applied, saying there's no extraction, but we flip the rule to say, if no gender is given, add female as the default gender. I know semantically it doesn't make sense, but I hope you get the point, right? So by just flipping this rule, which we apply after the extraction, the order gets valid and the gender is female, right? And with this powerful tool, our customers can fully automate their pipelines by just putting all their implicit business knowledge into our products. We have developed a visual editor for creating these rules on top of extractions. And at the end, we use Shackle as a technology to apply these rules to our RDF graph. So, but since the time is nearly over, I probably skip to the last thing. No, come on. Oh, sorry, I didn't. So let's summarize. AI can perfectly automate business processes also for small and medium-sized enterprises. And the foundations for success are, we need to separate all the atomic tasks in these processes. We need to apply generalized, or let's say dedicated models for these single steps. We need to have a generic data structure that we can use for all customers in the same way. And we need to have customer adaptations only by configuration, right? We want to have the smallest costs possible by just applying a configuration for a new customer. And at the end, only with the combination of AI and rule-based knowledge, we can have really success in the full automation. And rule-based knowledge is always needed when you have to have data validation or knowledge inferencing. So sorry for the delay, but thank you very much for attending. And I'm really open for some questions now.